As a quick summary of what's going to be covered in Section 2, we're going to talk about things about what happens on the celestial sphere from Earth's perspective. We need to take into account that Earth's a rotating object that is revolving around the sun, and we're going to use that to also explain things like the seasons, the moon's orbit around Earth. We're talking about the phases, and we'll talk about the sun, Earth, moon, and the shadows that they'll cast on each other. When we think of astronomy, one of the first things that comes to our mind is the idea of these constellations. And we need to emphasize here right now is that constellations are just arbitrary patterns in the sky. And they're just objects that we as humans project out onto the cosmos. So they have a lot of importance to us culturally. We would put our mythological heroes into the constellations, our religious icons. But what mattered is that the constellations inspired cultures to build objects to try and better study the constellations, try and find when the constellations were going to come about. Right? So, looking at, say, just one particular constellation, we need to point out that some constellations, their stars, well, lots of constellations, their stars are nowhere near each other. We'll associate stars as being next to each other from our view here on Earth, but they could be hundreds or thousands of light years apart from each other. If you look at it closely, some of the stars are going in opposite directions on very long time scales. So, on scales that are much greater than human civilizations, the constellations will have changed over time. Think about how the sun rises in the east and sets in the west. So if we can look at the Earth from the North Pole, we would say the objects are moving in a counterclockwise manner. Of course, the reality is that Earth is rotating on its axis counterclockwise once every 24 hours. So here on Earth, we can track the movement of the celestial objects in the sky, and we call this their apparent daily motion. Let us start to build our map of the night sky, called the celestial sphere. This is the projection of the Earth's rotation axis and equator onto the cosmos. On the celestial sphere, we find the stars and planets at different angular positions. Humanity, as recent as the 17th century, thought this was a correct representation of the Earth, of the universe. All the stars existing on the same sphere at the exact same distance away from us. Of course, we now know this to be wrong, but the celestial sphere still proves to be a useful tool. Here is a diagram of the celestial sphere. Earth's north and south pole line up with the sphere's north and south celestial pole. Same thing for the equator, Earth's equator with the celestial equator. The ecliptic is the sun's apparent annual path. If we follow that ribbon, you would see how high or low the sun gets at different times of the year. And don't forget to take note of this 23.5 degree angle between the celestial equator and the ecliptic. We see the stars projected on the celestial sphere, but remember, in reality, they could be vast distances separating them. Alright, now let's talk about coordinates on our sphere. We've got a declination, right, and right ascension. So we use these instead of latitudes and longitudes on Earth. Measuring declination, we start from the equator. And measure positive angles towards the North Pole. So equator, boom, boom, boom. 10 degrees, 30 degrees, 40, 50, 60, 90 degrees positive. All right, minus 10, minus 20, minus 30, minus 40, minus 50, minus 90 degrees. All right. As for right ascension, we would say measure in a eastwardly direction. So pick a point, start measuring 10, 15, 20, 30, boom, 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 all the way around. Of course, not all of us get the benefit of living on the North Pole and hanging out with polar bears. So we need to discuss what you see relative to where on Earth you live. So we can describe your zenith. And this is the point directly above your head on the celestial sphere. And your horizon sweeps out what half of the celestial sphere that you can see at any time. All right? So let's put you here at the latitude and longitude that you live on Earth and compare where you are on the celestial sphere. All right? Right, make reference to north and south, your zenith, directly below you, your nadir. Okay? Now, facing that south, sweep an arc that goes from south to your zenith and connecting to the North Pole of Earth. Right? That would be your meridian. Coming back to our full picture of the sphere, one thing we want to make note here is that in this view of the celestial sphere, it's not the Earth that rotates, it's the entire celestial sphere that is rotating about the axis connecting the north celestial pole to the south celestial pole. All right. Coming back to the ecliptic, we can talk about the sun's annual daily path. On this next slide, we'll have the beautiful representation of the sun's daily apparent path. So in this picture, we're looking at the sun during an Arctic summer close to the North Pole. And we see the sun at midnight due north, it will start to skim the horizon. And then as you go through the day, 6 a.m., rising, full 12 hours later, it reaches its peak height during this motion and starts to come back down and repeat. Now, to get a shot like this, remember that the Earth is actually rotating. So each picture actually has to rotate. You start looking north, east, south, west throughout the day. So, as a repeat, at the Arctic Circle during the summer, the sun does not set. It will come close to the horizon and rise back up and back down. Similarly, in the Antarctic Circle, the sun does not set during what's called our northern winter. Remember that I claimed that where you live on the Earth determines what you'll see in the night sky. So let's actually look at some diagrams to put these pictures in context. So let's say you live at the North Pole. Your zenith lines up with the North Celestial Pole. Your horizon, this would be your horizon, projects out onto this top half of the celestial sphere. So, no matter what, any time of the year if you live in the North Pole, you will always see these stars. But notice that these stars are always outside of your view. Specifically, Earth will always obscure your vision of them. So, when you live in the North Pole, you will always see half of the celestial sphere. Now, what do you see for the stars? Right? You'll look at the North Celestial Pole, and you'll see the northern star, the star closest to our northern celestial pole. I always like to use these for directing northerly. And you'll notice that all the other stars are what we say are circumpolar. They circumnavigate around the polar star. Now if we move to the equator. On the equator, here's your horizon, right, this disk here. But remember that as you rotate around the Earth, you get to see the entire celestial sphere at some point in the day. So no part of the celestial sphere is ever cut off from your view. This is why for big astronomy, you want to put your big telescopes near the equator, high up. You want to get as high as you can into the mountains if possible, near the equator, so that you're guaranteed to see the entire celestial sphere at any point in time during a day. Right? Now, on your horizon, you'll see the North Celestial Pole. And instead of seeing stars as being circumpolar, we describe them as having a rising and setting. Right? Stars will come into your horizon, they will rise up, and they'll set. Now, what if you're at an intermediate latitude, like myself here at Old Dominion? Here you'll have this conic section. So let's say you're right here, your horizon spans this region of space, and you've got Earth blocking some part of your view. So on the celestial sphere, we'd say this is what is visible to you, but there is this conic section of the celestial sphere that gets blocked out of your view. You'll never be able to see these because the Earth is blocking them. So as Earth rotates around, you get a percentage of the celestial sphere you get to see. We'd say that you can always find the North Celestial Pole. Some stars will be circumpolar, Other stars will have to rise and set. Recapping all this together now, if you live at the North Pole, this would be your perspective of the celestial sphere. The half that you can see, the half you can't see. So at any point, half the sky is visible, and you'll see all the stars being circumpolar. Now, if you say lived at latitude 30 degrees north, this would be your view, where the celestial equator has been rotated around. You'll still see the North Celestial Pole. You'll see some stars that are circumpolar, and other stars that will rise and set as you rotate around. Move on down to the equator. Now the celestial equator is akin to your meridian. Right? As you rotate around, all stars will rise and set, except for the North Pole, of course. That will be on your horizon. And finally, move to 30 degrees south latitude. This will be your view of the celestial sphere. The North Pole is out of your view, but you'll still see stars rise and set and circumpolar around the southern celestial pole. Now, for an actual picture of this, let's look at this. If you're up in northern Canada, this is a time-lapse photo, and we see the stars going around the northern star. And if you go to a lower latitude, right, you take the northern star and you bring it closer and closer to your horizon, and we see stars rise, set, and others circumpolar.